Welcome to the IoTSyS demonstration. IoTSyS is an integration middleware and communication stack for the Internet of Things. It allows to integrate existing home and building automation technologies, smart meter technologies, and other information services into the Internet of Things. And it can also be deployed as communication stack on constrained sensors and actuators nodes based on 6LoWPAN. The integration middleware and the communication stack is using OASIS Open Building Information Exchange for a common object representation for heterogeneous technologies, and it provides various protocol bindings optimized also for the deployment within 6LoWPAN sensor networks. And different message encodings are supported depending on the use case. It exploits IPv6 features, and there's a Java-based implementation for the gateway with protocol bundles for different technologies. And there's also a Contiki-based implementation for constrained sensors and actuators. The key features of the stack are the integration of these heterogeneous technologies based on web services and a common device representation, and the use of IPv6 addressing on every data point. And based on that, a powerful group communication that relies on IPv6 multicasting, providing a peer-to-peer communication for wireless sensor and actuator networks. And also a convenient HTML5 based control and engineering user interface that is directly shipped with the gateway and allows to build control logic or to interface directly with the devices. And everything is open source. IoTSyS is tested and developed with an extensive testing lab at the Vienna University of Technology. So the lab room itself is automated with KNX and provides automation for lighting control and presence detection. There's also some blind actuators and contact sensors at the window, air conditioning, and the room thermostat. Further, there's a simple KNX test lab. And there's also a BACnet HVAC room model that is automated using BACnet controllers and used to heat and cool a simulated room. And for that, all the waves, fans, and heat of a simple model are controlled using BACnet. And we combine it with new Internet of Things smart objects like 6LoWPAN temperature sensor that can be used to measure the current temperature. And all the devices you can see are accessible through IoTSyS with this IPv6 address for each device, and also the web service based interaction interface. And there's also a smart meter that allows to measure the energy consumption in real time. And there's also a meter for a simulation of a heating, floor heating model. Finally, there's also an RFID tag reader integrated that can be used for access control, where an electronic door opener is also controlled using KNX. For smart objects, we use a 6LoWPAN testbed based on 6LoWPAN modes that provide accelerometer and also a temperature sensor on board. And for demonstration purposes, we also have a mobile testbed consisting of all these technologies that combine BACnet, KNX, 6LoWPAN, and an Ocean for some nice demonstration use cases. For the integration middleware, the Java-based gateway can be deployed on the popular Raspberry Pi board, as you can see here. And there are, for example, also some extensions to directly interface with the bus technologies. Here, for example, you can see an extension board that allows to directly interface the KNX Twisted Bear bus. And most convenient is also just to use USB communication modules that can be simply plugged in the USB port. We can also deploy the gateway on custom-built platforms, or, for example, on existing 6LoWPAN border routers. The gateway uses Java based on the OSGI framework for a modular and component-oriented design, and there are protocol bundles for all the different technologies integrated. and an OBIX server that provides the different HTTP and CoAP interfaces. Further, the gateway ships with a HTML5 user interface directly on the gateway, and also the group communication service and some discovery services are implemented on the gateway. So, to illustrate the group communication mechanism and the user interface, here you can see a screenshot of the user interface provided by the gateway. On the left side you have an object browser that allows to query the different devices and data points of the integrated technologies, and by simply drag and drop you can put it into a canvas area where each device or data point is represented through a generic OBIX user interface. So for basic value objects like booleans or numeric fields, you have a user interface and you can directly interact with the device. And you can further wire different devices together by using this drag and drop connectivity. And once you connect different data points, the gateway stores an IPv6 multicast address for these connections. And for gateway-based integrated technologies, the gateway takes care for this group communication mechanism. But for 6LoWPAN-based sensors and actuators, the multicast address is stored for this data point. And in that way we can use IPv6 transient multicast addresses for each communication relationship, and the devices can directly interact in a peer-to-peer way without needing the gateway, for example, for 6LoWPAN. So if you wire the devices together like a light switch and a light switch actuator, then there's no gateway interaction needed anymore. But you can also integrate 6LoWPAN based sensors, for example temperature sensors, with existing technology by using site local multicast addresses, and in that case the border router, which we have modified, is forwarding these site local multicast addresses. And for the data exchange, only the simple OBIX value objects are exchanged. IoTSyS is developed and maintained by the Automation Systems Group of the Vienna University of Technology, and all the software is open source and available at IoTSyS.org. In the first demonstration we will show how the IoTSyS integration middleware can be used to link heterogeneous technologies together. We will use an Ocean push button to control KNX room lights and a BACnet HVAC model. Further, we will show how we can use an RFID tag radar together with a KNX door opener. For this demonstration, we use the Raspberry Pi to operate the Java-based gateway. We connect the gateway with KNX, BACnet, RFID, and an Ocean technology. Here you can also see the Ocean transceiver attached using USB. The gateway provides OBIX lobby to provide an entry point to all the available objects that are accessible using HTTP and XML. And once you know the URI of an object, you can query the object. For example, here I use the HTTP requester plugin, and I simply query, for example, the KNX switch of the light of the lab room. And as you can see, the object representation of the device is returned, and it has one data point which is of type boolean representing the channel. So I can also only query this channel, and since it's a basic boolean, I can simply switch on the light by making a CoAP put on this UI. And as you can see, the room light goes on, and I can turn it off again. It's also possible to request the object in a different encoding. So we can simply request, for example, a JavaScript object notation. And as you can see, then all the OBIX objects are returned in a different encoding. But this interface is nice for machine-to-machine communication, and also the CoAP-based interface works similar. But for human beings, it's more convenient to have a graphical user interface. In this case, we can use Obelix, which is also directly served at the gateway. and it parses the OBX lobby and provides a convenient object browser to query for devices. So for example, we can retrieve the OBX representation of the Enotion button that is next to the gateway. And I have already inside the user interface the object representing the switch. So again, I can simply turn off and on, turn on and off the light. Enotion is a technology that is based on energy harvesting. So within the button is push button is no battery. It simply gathers the required energy from the press of the button. And as you can see now, the button is not linked to any device. So if we press the button, currently there's no functionality, but you can see the update in the user interface. And if I want to integrate it with KNX, I simply drag a connection in Obelix, and now the multicast group communication is established between these two objects. And if I press again, you can see that it now controls KNX. Now we can also add other technologies to this group communication. So, for example, we can add some backnet devices, like the cooling aggregate. And again, I simply connect the devices. And now if we have a look on this cooling aggregate, we can also control it with the Enotion push button. And as you can hear and see, now the backnet controlled cooling aggregate is also controlled by the Enotion button. Now we can also add other devices to the communication group. For example, we can add a backnet cooling aggregate. So currently the button is not linked to the cooling aggregate. So if we put the button next to the cooling aggregate and we press it, only the light is controlled. Now I simply connect it at runtime with the cooling aggregate. And now also the cooling aggregate and the light is controlled by the button. We can also add an access control component, for example from KNX for the door opening. And if we have a look on the lab door now, it's like closed. And if I add the communication relationship, and the button is pressed, you can hear the door opener that provides access to the lab. And if we turn off again, all the communication objects linked are set to false. I can simply remove the control logic by double-clicking on the connection lines. And now I have removed all connectivity of the button. So if the button is pressed again on the on state, nothing happens anymore. As next demonstration, we will include the RFID reader in the setup. So here we have the RFID reader connected to the Raspberry Pi gateway. Now we simply add the RFID reader and we activate the continuous read. And if we put the employee card on the reader, we can see the identity code. And like for more complex control scenarios, we can also use logic components, like in this case, string operator. And here we simply wire the RFID reader output as input value. We activate him, and the result is connected to the light and to the door. So if this employee enters the room, then the door and the light is switched on. So we simply change the employee card. Now we can see, okay, a different identity code, and if we change it back again to the first identity card, you can see the door opener is activated and also the light is switched on. In the second demonstration, we will show how we can deploy the IoTSyS stack directly on 6LoWPAN based devices and how the interworking with existing building automation technologies can be done using the gateway. For that purpose, the gateway is operated also as a 6LoWPAN border router. For this demonstration, we will show how 6LoWPAN based devices using the IoTSyS stack can interact with existing home and building automation technologies. For that purpose, we have equipped the Raspberry Pi based gateway with a 6LoWPAN mode to act as a 6LoWPAN border router. We use a 6LoWPAN mode with the IoTSyS stack on board as a simulated button, because there is an accelerometer inside and we can simply tap it to emulate the button. And we will link it to a light bulb provided in the mobile IoT suite case based on KNX. So again, we have a device representation in the Obelix user interface. So we have a proxy object with the button that can be dragged to the canvas, and we can also add the according data point of the KNX switching object. So now again, I simply connect the according data points together, and once this is done, the according IPv6 multicast address is written down on the device, and every time it's tapped, a multicast is sent out that is received by the gateway, and all the aligned objects are also updated. Now if we take the device and tap it, we can control the light. Now we can also add another device, for example a sunblind actuator. And now if the button is tapped again, we can also control the light and the sunblind actuator.